going to be working on translating expressions, equations, and inequalities. So to get started, we're going to make a list of some keywords and phrases that can help us know what operation we're going to be doing. If we were together, then we would brainstorm some of these, but since we're not together, you'll just make the list like I am. So let's start with addition. Probably the most common way we know we're doing addition is we see the word sum. Sum always means addition. We might also see total, like how many do we have in total? Of course, we'd see plus if that happens to come up. It could also be increased by, or it could be more than. So those are all words that we might use for addition. For subtraction, the opposite of sum is difference. So that's the answer to a subtraction problem. Instead of plus, we would see minus. Instead of increased by, we would see decreased by. And then instead of more than, we might have less than. And subtracted from is another one. So what we have to be careful with on subtraction is that the order matters. So when we're working with less than and we're working with subtracted from, we have to flip those around because the order will matter. So we have to be careful on those. Let's go on to multiplication. On multiplication, we might see times, like 4 times as many. That would be common. The answer to a multiplication question is product. Oops, there's nothing else after the T. Sorry, just product. We might see of, like how many of, like 4 out of 5 or something like that. We might see twice or 3 times as much. That would be multiplied by 2 or by 3. Or you might see things like double or triple. We don't usually do quadruple, but I guess in theory it could be. But it's just telling how many times you're multiplying. Division, good news, there's not quite as many. The answer to a division problem is the quotient. So we've got that one. We might also see something about separating. So if we have to separate something into certain groups or quantities, that would be division. Of course, divided by, that would be obvious. And we might see something like split in half or in thirds or something like that. That would indicate a fraction, and that would be division. So those are our big 4. Let's go on to the parentheses and the turnaround phrases. So the parenthesis phrases are things that we're going to put in parentheses. So if we see something, for example, like times the sum of, that indicates, if that's a U, the sum of, that indicates that we're going to be multiplying something times something that's been added, and we need to do the addition first. If we have times the difference of, or the difference between, that would be another time, oh goodness, that would be another time that we would want to be using parentheses. The difference of, or it could be the difference between, so I'll put between on this one. And the turnaround phrases, those are the ones we start up above. That means we have to do it in the other order because of the rules of subtraction, because we don't have commutative property of subtraction. So we have to turn these phrases around. That would be less than and subtracted from. So this is a really helpful list to help us know how to handle these translations. So let's look at a few of these. So on number 1, it says the product of a number and a 3. Well, we know product means multiply. So that would just be 3 times n, or 3n. Number 2 is the difference between a number and 10. So we can look up at our list up here, and we're looking for difference between. I do see difference between on the parentheses, but it doesn't say times a difference between. It just says the difference between. So if I keep looking here, I'll see that here in the subtraction, and I can see it on difference. So you can't really see where I'm pointing, but I was definitely pointing there. So the difference between n and 10 is going to be n minus 10. Okay, the quotient, we know quotient means division, and we just do it in the order it says, the quotient of a number and -5. And then 4 subtracted from a number. I want you to go ahead and put a big star by number 4. This is how I'll know you'll be listening to this and not just writing down what I say or what you see on the screen. You're actually listening. So you're going to put a big star at number 4. We're doing 4 subtracted from a number. So we're going to start with the number, and then we're going to subtract 4 from it. So that's one of those that you have to flip around because of the subtracted from. Number 5, the sum of twice a number and 7. The sum of twice a number. So we have two things going on there. So sum means it's going to be some addition. Twice a number is 2n and 7. And we've got it. And then number 6, the product of a number and 10 increased by 1. So the product of a number and 10, product of a number is going to be multiplication. So that's going to be 10 times n. Then we're going to increase it. We increase by adding. Okay, we can go ahead and finish these up. Number 7, 4 less than a number squared. Well, less than is one of those that we have to turn around. It is this one. Less than is a turnaround phrase. So when we have 4 less than a number squared, we're going to turn them around. So we're going to start with our number squared, and then we're going to do 4 less than that. So the less than is a turnaround. And the last one, twice a number divided by 5. So here's our big key, twice a number divided by 5. Twice is also 1, isn't it? So twice a number is 2n, and then we're going to divide it by 5. On this next little bit, we are going to be working with equations. And the difference here is that they're going to have an equal sign. So on an equation, we're looking for the word is. When we see the word is, we'll put an equal sign. So we have the sum of twice a number and 10. Well, sum means add. So we're adding twice a number and 10, and it is 36. In math, when you see the word is, that means equals. Let's just work our way down. Number 11, 4 times a number divided by 8 is 3. Is 3. So 4 times a number, 4n, divided by 8. Oh, just divided by 8. I didn't have to leave all that space after all. That's it. 4 times a number divided by 8 is 3. Number 13. 1/2 of a number is 8 less than the number itself. 1/2 of a number. So 1/2, oh goodness, 1/2 of a number is 8, less than, that's one that I have to watch out for, 8 less than the number itself. So it's going to be n minus 8 because that less than is a turnaround phrase. We have to flip it around. Please go ahead and work number 14 on your own, and I'll check it tomorrow in class. Number 15, we have 15 decreased by the quotient, decreased by the quotient of a number and 3 is 20. Okay, I've got the is 20. I got that part down. Okay, 15 decreased. That's not a turnaround, so I can just do it normally. 15 decreased by the quotient. That's division. We have a quotient of a number and 3. I don't know why it keeps doing that. That's annoying. Okay, there we go. All right, now let's talk about inequalities. On inequalities, that's when they're not equal to each other, but they are still related. So we have less than or equal to, and that's going to be like that, greater than, and greater than or equal to. So those are our inequality symbols. Let's see if we can do these. A number is less than 10. So our number is n, is less than is just our less than symbol, and we have negative 10. Number 18, a number is less than or equal to 8. So a number is less than or equal to, that's going to be our less than or equal to symbol, 8. Okay, those are pretty straightforward. Number 19, a number is greater than or equal to negative 4. A number is greater than or equal to negative 4. So that's that one. Okay, number 20, it finally starts to get interesting. A number is at most 45. That's not one of our lists up there, is it? So a number is at most 45. So if I said we could have at most 45 people in my house, could I have more than 45? No, 45 is the most I could have. So that means it has to be less than 45. Now, could I have exactly 45 people? Well, yeah, I think so. I mean, if it's at most 45, that means I could have 45. So it is less than or equal to. So if you put those in kind of a real context, maybe that will help. Go ahead and drop a little picture over there of what you think Mrs. Shaw's house looks like. It should just be a little drawing of a little house. And you don't even have to put the 45 people. Just draw a little house. Number 21, a speed limit of 55 miles per hour. Okay, so the speed limit is our N, and it's 55. So if it's a speed limit, does that mean I can go faster or slower than 55? Well, I have to go slower than 55, or I could go exactly 55. So it would be less than or equal to 55. Number 22, a number is at least 16. So we've got our number, and we've got 16. At least 16. So that means you have to be at least 16 to drive. So that means you have to be bigger or older than 16, don't you? Or you could be equal to 16. So that could work as well. We'll go ahead and finish up these last 4 as well. A number is no less than 10. Okay, so we've got number, and we've got 10. So no less than. Okay, I can have no less than 10 people. So if I can have no less than 10, that means I have to have more than 10. Or I could have exactly 10. Number 24. A number is no more than 26. Okay, a number we're thinking of is no more than 26. Let's think about what goes there. No more than 26. Well, if it's no more than, that means it has to be less than, or it could be equal to. And 2 more, a maximum number of 25. Okay, maximum number of 25. That means, let's see, if 25 is the max, then the number has to be less than that or equal to it. And a minimum number of 5, let's think of a context for that. I have to have a minimum number of 5 students in the class. So that means I could have 5, or I could have more than 5. So putting those into a real life context, I find is helpful to helping me know which way the inequality should go.